Hey there everyone, here we are doing one of those sketch the function problems. There is a lot of information to unpack here, so you just want to go slowly, carefully. A lot of times you have to draw a rough draft, you make a mistake, and then you clean it up later. All right, so start with those thumbtack points. That's a great place to begin. F of -1 equals f of 3, which is 2. So -1 is 2, 3 is 2. And check them off as you go. F of 0 is 1, and f of 2 is 0. Lots of ways to make mistakes processing them at the end of a long day. Here, the first derivative of -1 is the same as the first derivative at 2, which is 0. So at -1, I'm going to have a horizontal tangency, and at 0, I have a horizontal tangency there. Then there'll be a vertical asymptote at -3, so I'll just sketch a guideline there. And concave up, I took out the second derivative being greater than 0 here. That's concave up between 0 and 3. Concave up between 0 and 3 makes a lot of sense. It's going to go down, touch there in one point. No shenanigans going on, pretty standard. And then it is also concave up less than -3. Concave up less than -3. Okay, so we know if it's concave up here, it's going to be going something like that. And to be concave up forever and ever and ever, amen, means it's got to be approaching a horizontal asymptote, because there's no way, well, no, it could be like a parabola, I guess. So as long as it's concave up forever, it could, yeah, it could be sort of parabolic going like that. So we don't really know what it's doing. So that's concave up there and there. Concave down from -3 to 0. Concave down. Okay, now that makes sense also, that it's going to link right there and then go down with that asymptote again, concave down. And then also it's concave down from 3 to 6. All right, concave down from 3 to 6 just means that it's only, it could be anything like this. Yeah, it could, a lot of options there. Then the last thing is that there's a limit as x goes to infinity, it approaches 3. So there is a horizontal asymptote. So it cannot be below this unless it did something very strange, or well, it went like this and then just went straight. So I'm thinking that it's going to go up, and then there'll be an inflection point there, and then it'll approach. But there's for concave down. See, if it turned around, it would be concave down, or concave up rather. Concave up, there'd be another interval, and there it's not really saying that. So I think that you got to just draw something concave up until it gets to exactly 3, so 6, 3, and then it just goes straight like that. I'm ruling out the fact that it can't go down, because if it went down like this, it would have to turn around and go up, or if it went above, it'd have to change concavity, and you'd see a concave up beyond 6, and there is not. So I think that our only option is to do something like that. Okay, that's a bit tricky. Then, having done all that, ask ourselves, are there any inflection points? There's an inflection point there at 0, 1, so that's at 0, 1. And there's an inflection point here at, what is that, 3, 2. 3, 2. And what is the limit as it gets closer and closer to -3 from below? That's got to zoom up this way. Otherwise, you would not be able to be concave up. So that's infinity. And then what's the limit as x goes towards -infinity? We really don't know. That is a great big question mark. Question mark. Cannot be determined. Can't be determined. CBD. I don't know. And then, is there a horizontal asymptote? Yes, at the limit. So at y equals 3, there's a horizontal limit, horizontal asymptote. Are there any maxima and minima? Local max, local min. There is a local maximum, local max at 1, 2, negative 1, 2. And there's a local minimum, local max I should write because they both start with M, local minimum at 2, 0. And if this is correct, and that's a bit of a stretch, there's no one point, but we know that there's a maximum value, but it's not asking that, it's asking for points. So we will stay away from that because you'd have the line apparently from there on out is all local maximum because anywhere on either side is equal to or less than. But I think on the assessment we will stay away from trickier things like that. So there we go. It's not a totally neat and tidy problem, but that is one possible solution. Good luck, everybody.